Okay, chapter 4, forecasting. Forecasting is predicting, right? I like play golf. I like to play golf. So always I concern about the weather. So weather.com, and then what's the weather coming weekend. They forecast, right? Then I can use that forecast. Forecasting is predicting. Okay, to me, weather is my concern, right? So I look at the weather. Okay. To the company, demand is the most concern forecasting. If I'm a manufacturer, then if I know future demand, then I can plan, right? How many products I should produce, right? So to the company, demand is the most important forecasting. So forecasting is about demand management. Purpose of demand management forecasting, coordinating and controlling all sources of demands. We should know, right, future demand. Then if I know next, let's say a week, demand is 100, then I can buy resource about 100, right? But if I don't know, then maybe then buy material about 100 product resource. And demand is only 50. Something cost, right? If I buy 100 much resource, but demand is 150. There is demand, but because we don't have product, so we can sell, right? Out of stock. That also cost, right? So right amount of future demand we forecast, then we can plan right and then efficient, right? So forecasting and demand management is also in operations management. Make it better, cheaper, faster, okay? There are two types of demand: dependent demand and independent demand. If I'm a car manufacturer, I'm not good at drawing, but briefly, what looks like car, right? Passenger car, tire, right?
Do we have a window?
I don't care window. If I know next month is car demand, let's say 1,000. Automatically, I know tires demand, right?
Exactly.
how many?
4,000.
4,000 times 4 equals 4,000. Okay. Cars demand is final product demand, right? Final product. Tires demand is part, right?
Yeah.
Components or material, right?
Mm-hmm.
Dependent demand, the demand for product or service caused by the demand for other product or service. Okay. Part, tire. Tires demand caused by something.
So it would be the dependent.
Car, right?
Mm-hmm.
So parts or component material demand is dependent demand. Independent demand, demand is not derived directly from that of other product. Independent, right? Cars demand. Final product demand is independent. So dependent, parts, components, and so on. Final product demand is independent. Okay? Components of demand. If demand up and down like this, actual demand, then average demand, you know average, right? Add all of them and divide by the term, right? Here. And seasonal element. Seasonal element. Up and down, up and down, up and down, same pattern again and again.
Mm-hmm. Christmas. and go
Season, right?
Mm-hmm.
Ice cream demand. For example, ice cream demand.
Summer.
Usually summer high, winter low, and then spring, fall, about average, right? And then next year the same pattern, next year same pattern, and so on. So same pattern again and again because of season. That is seasonal element. Next one, cyclical element. The same as seasonal element. Up and down, same pattern again and again, but term is 2 or more years. In 1 year, seasonally move seasonal element. 2 or more years, same pattern again and again, that is the critical element.
Just over 2 years, 64.
More than 2 or more years. Financial market, usually same pattern again and again, longer than 2 years. Like every 5 years, same pattern or something like that. That is the cyclical element. Random variation. There is no pattern, move itself. Then we cannot forecast because it moved randomly, right?
Mm-hmm.
And trend. Up and down, short term, but long termly, it goes up
Trend
like
up.
this, right?
Mhm.
So in this demand, trend is increasing trend, right? There are some types of trend. Linear trend. Linear. Y equals A plus X, something like this, dx. So if we draw this one, then looks like this function. If exponent of x variable, we call that independent variable. Exponent is 1, then this line is straight. If it's 2 or more, 2, 3, 4, 5, 6, then it's not straight line, curve. So if exponent of x variable, independent variable is 1, then straight, then we call this linear trend. Increasing trend, decreasing trend, maybe stable. And then S-curve trend. You know, have you taken kind of introductory or principles of management? Do you know product life cycle? Product life cycle. Have you heard?
Yes.
Okay. What looks like? It looks like, right?
Mm-hmm.
Oops. Typical product life cycle
Mm-hmm.
S-curve. What do you call first phase?
Mm-hmm.
Introduction, right?
Yep.
And then maybe develop, mature, and decline like this.
That's
Product
right.
life cycle. Okay. And then two other types of trend. Looks like this, asymmetric trend. Looks like this, exponential trend. Guess which one is for new product trend? Which one? Guess.
The eccentric trend.
This one?
Yes.
Yes.
No, I think this one.
This one?
That one.
Voting. I will follow you voting. Look at this. Product life cycle.
Mm.
Introduction part
Oh, yeah.
for new product. What it looks
Exponential.
like.
Exponential.
Mm-hmm.
Yeah.
So first time
Mm-hmm.
and then demand increase small by small, but later lot, right?
Mm-hmm.
So people know more and more, and then demand increase, right?
That was in marketing.
For this one, already nurtured, developed and nurtured this part, right?
Mm-hmm.
So already introduced and then developed.
Developed.
So this one for new product, and this one for a kind of mature product. This one, increasing rate is high, but later taping up and then disappear like this. So trend, exponential trend for new product, and then already there. Straight and S-curve. There are two types of forecasting, quantitative and qualitative. Qualitative, without number, using opinion or something, forecast. Subjective and judgmental based on estimate and opinion. My base campus is Montgomery, and then in Montgomery, Hyundai, and then there are many suppliers,
Mm-hmm.
and then almost they are Korean. I'm Korean too. So I made relationship with them. And sometimes I ask, what's next year's Hyundai demand? And the person said, it will be increase. Okay, how much? About 10%. I trust. If I'm a supplier, then I should trust, and then I prepare 10% increase, right?
Right.
Without numeric data, just their opinion, forecast, right? That is qualitative and quantitative using number. Time series analysis and causal relationship. Time series analysis and causal relationship is similar. Anyway, using past data, if you are, you take, you're going to take certain course, and then if there are multiple courses open, then different instructors. If you have past data, such as student average score or grading average, using past data, then you can decide, right?
Right.
That's better, right? So, forecast future demand or something using past data. That is quantitative, using number. Time series data, we call time series data. Y equals A plus BX, right? Then something like this. Usually, quantitative forecasting using independent variable, X variable, forecast Y variable. If X variable time-related data, something like this, January, February, and so on, then change time, then demand change, X variable, Y variable, using X forecast Y variable. If X variable time-related data, we call this time series data, using time series data forecast, that is time series analysis. And causal relationship, cause and effect. Y equals A plus BX. Using X and we forecast Y variable. This one can be cause of Y variable, that is causal relationship forecasting. For example, temperature and ice cream demand. Temperature increase, ice cream demand usually, right? Decrease and decrease. Find their relationship. How much increase and how much increase? Relationship. Then develop this kind of formula or equation, then using that equation forecast, that is causal relationship. Okay. Qualitative techniques in forecasting, judgmental method. Ask my example, ask Hyundai people, then follow their opinion. That is judgmental. Jury or executive opinion, and sales force composite. Ask a dealer. Sales force, right? dealer, what do you think next year's demand, then they say, then follow that opinion, like that. That is judgmental method based on a process of collecting educated opinion. Something people have experience, as educated, ask them, then follow. And secondary source information using published opinions such as consumer market survey and Standard Poor index, something like that, using secondary source, publish it. And Delphi method, this one is similar to judgmental method. Instead of asking individual, ask certain group, made by expert, professor, statistician, economist, and something practitioner, make group, and then ask them. They follow the steps, and then change opinion to number, and then using that number and forecast. That is Delphi method. Okay, time series analysis. Time series. X variable is time series data, such as time, first week, second week, and so on. Then Y variable. Simple moving average. Useful for removing the random fluctuation. Okay. If demand, actual demand up and down like this, fluctuate, then using the simple moving average, make it smooth like this, and then we can use this smoothed data for forecast. Or using that itself forecast. Simple moving average is just add and divide by the term, simple average. If I want to forecast first and third and then fourth, F4 equals previous three terms. If we use three terms, simple moving average, just add three previous terms and then divide by 3. If we use 9 terms, and then 9, so add 800, 1400, 1000 divided by 3 equals 10, 6, 7. Next term, F5 equals 1400 plus 1000 plus 1500 divided by 3, 1300, and so on. And then if we use 9 terms, if we forecast F10, then add 800, 9 previous terms divided by 9 equals 1367. If we forecast F11, previous 9 terms divided by 9 and this one. This is simple moving average.
Why are you leaving out the 800? When you change it, it adds, go back one.
9
When you did-
terms,
Uh-huh.
previous 9. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Oh,
Okay?
okay, sorry.
And then weighted moving average. You know weight average, right? Simple average roll are the same, right? I mean, 10 plus 11 plus 12 divided by 3 equals 11, right? That is the same as 10 times 0.333 plus 11 times 0.333 plus 12 times 0.333, like this. That is the same as 11. So this one's roll, this one's roll, this one's roll to make this one is the same. 0.333, 1 over 3, right? That is simple average. But sometimes most recent data is most important, right? That case give higher weight, less like this. Different weight, something like this. Most recent 95 times 0.4, next 0.3, and so on like this. Different weight. Using different weight, that is weighted moving average. So example, next one, the same average weight, but anyway, total weight, sum of weight should be 1. 0.4 times plus 0.3 plus 0.2 plus 0.1 is 1. If I use 3 terms, then may I use 0.5, 0.3, 0.2 like this. It should be 1. Maybe you can use 0.4 plus 0.4 plus 0.2, 1. That is weighted moving average, just to show you, because they are not in test, not in quiz. So go quickly. Exponential smoothing. Exponential smoothing. Weighted moving average, you can use whatever weight, depending on which one is important. Exponential smoothing, the idea of this one is the most recent occurrence are most or indicative of the future. That means most recent data give higher weight. Using this formula, then we can find weight like this when alpha equals 0.05. We call alpha smoothing constant. Smoothing constant. This one is given. If alpha is higher, then less smooth. Lower, then smoother. Flat. Use lower alpha, smoothing constant alpha, flat. Formula, forecasting certain term equals forecasting one earlier term plus alpha times this one is given A actual one term earlier minus forecasting one term earlier. Example, the last month is forecasting, this is FT. T minus 1 last month, and then actual, that is A T minus 1. Then alpha is 0.01, then using formula, FT minus 1 is 22,000 plus given alpha is 0.01 times actual t minus 1, 21,000 minus 22,000 equals 21,990 logs. This is exponential smoothing method. If I cover a fest like this, that means not in test.
Good.
Exponential smoothing with trend. The problem was problem using exponential smoothing is lagging behind. Actual demand lag 1 using alpha smoothing constant 0.5, then smoother, then actual demand peak is here, but alpha equals 0.5, peak is here. One term delay, right? 0.3, more delay, right? 0.1, more delay. So using low alpha, then flatter, then lagging behind. That is problem and then error. Correct that error using another smoothing constant, delta. Then formula complicate. And this one will be in quiz and test.
Oh my God.
So wake up. Wake up. FIT forecasting including trend. FITT equals FTT plus TT. If I want December forecast, and 12 like this. Then this one is this one, so 12. Forecasting 12 equals FIT, T minus 1, T is 12, T minus 1 is 11, right? Alpha given, actual T minus 1 is 11, FIT 11. Then this one is this one. T12, trend 12 equals trend 1 earlier, 11. Delta will be given, and FT is this one, 12. And then FIT 11. Okay? Looks complicated, but find one by one, plug in, then that's it. Okay? Example. T12 equals F12 plus T12, right? F12 equals FIT11, right? Plus alpha A11 minus FIT11, right? Am I right?
Yes.
T12, this one, equals T11, right? Plus delta times F, this one, 12, minus FIT 11. Sure, this will work on that. F11, T11. T11 is given, right? Good. Alpha is here, good. A11, this one, good. Delta is here, good, right? Right?
Mm-hmm.
You can find, right? Plug
Oh,
in.
yes. Mm-hmm.
F12 will be after calculation, right? But FIT11 is not given. How can you find?
Plus you want to find F12.
Right? Right?
Yes.
If you know this one, then you can get this one, right? FIT11 equals 11, right? F11, 100. T11, 5. 100 plus 5 equals 105. Now we know FIT11. What else we should know? Plug in, calculate, and then add. Complicate? No. So FIT11 equals F11 plus T11 equals 100 plus 5 equals 105, right? Then F12 equals 105 plus 0.1 times 110 minus 105 equals 105.5, right? Then this one, 105.5 goes there, F12, then plug in others, and that's it.
Is this on Blackboard too?
Yes. Question?
Do we need to know, will you give us the formula, or will we need to memorize it?
What do you want?
Well, of course, give it the formula.
Exactly.
Do we need to?
Always, my class, when you take quiz, final, open notes, you don't have to memorize anything. Just understand. Okay? You don't have to memorize. I will not give you a formula, bring yours. Question?
No, just scratching.
Scratch. Okay. Practice problem. Second last page. You know, you can do A and B. Try question number C. Number 1 and C. Try. I will give you 5 minutes. Try and find what you don't know. Okay? What you know, what you don't know. Not A, not B, C.
Oh, I thought you said one. Okay, one.
1C.
Okay.